big, so it should be fine. Thanks for the introduction. Yes, my name is Soraya Hausl. I work at ASOS.com. I'm leading the data science work in the recommendations area there. And today I'm just kind of going to talk to you about how we implemented recommendations, the sort of challenges we had when putting data science into practice. For those of you who don't know ASOS, we are an online fashion store, or actually a fashion destination for 20-somethings. This is our focus group. We have about like 14 million active customers, which means people who shopped in the last year, about 85,000 products at any time on the site, and about 1,000 brands. So this makes up for a lot of interesting data that we can use to power our data products. So data science at ASOS, what do we do? We mostly are active around these 4 areas. On the one hand, recommendations, which is all about helping the customer to discover products and inspire them. Product understanding, where we're looking at using our product data more and more intelligently, where we're looking into enrich it with visual and textual features. We do work in customer understanding, which has things like churn prediction, customer lifetime value prediction, customer segmentation, and just predicting what the customer does next in a session or between sessions. And then retail or retail analytics, where we're looking at forecasting product life cycles. The work that we do is mainly around developing actually data products, so building data products, as opposed to doing more work around insights. So personalization, why do we bother? I guess as many other companies, we see the value in it, and a lot of our competitors do it. So we found that customers more and more expect companies to use their data to customize the experience and only show them things that are relevant for them. We found that it's a problem solver for us. So we have a lot of products on the site, and we constantly get the feedback from customers that they can't be bothered to look through everything. It's too much. They're a bit overwhelmed. So personalization and recommendations are a means for us to actually just show you what we think is relevant for you, customize the experience, and also we avoid that you see, or hopefully we avoid that you see a lot of things that are irrelevant to you. We also saw that it's a growth driver for us, so it's an area of innovation, which means that in the trials that we've done, we saw that we can use it to increase traffic, we can use it to increase conversion, which is ultimately very beneficial for us. And then it's definitely now enabled by data. So if you think about it, a couple of years ago, we wouldn't actually have the means to process the data, or we wouldn't have had the data in the first place. But now, because our customers are also more in the younger part of the population, so they use their mobile phones for everything, they're willing to share their data, and we're able to collect it and use it. When we're working on getting data science in front of the user, there are 3 main phases. So there's the whole phase around discovery, model building, model evaluation, and ultimately optimizing the model. So for us, it looked like in the following way. We worked on, in the beginning when we started to think about recommendations, we did a lot of hypothesizing and research around what this could look like, what are the sort of potential problems. We talked to people in the business to find out what are the challenges, how can we incorporate them. Then we spent some time on actually developing the algorithm and developing a working prototype that we can actually then put in front of either some test users, or also we did a lot of offline testing using historical signals. We then went out to productionize it and scale it up, and ultimately did a lot of online testing where we actually put it in front of our whole customer base, either on the app or on the website. And there we were able to collect a lot of data around how does it perform, what's the feedback, and that we use then to kind of constantly iterate, learn, and improve our algorithms. And today I'm going to talk about a couple of challenges that we had along this process. So our recommendations journey, we started out with recommendations a couple of years ago. I remember when I joined the company, I was only the second data scientist, and at that time, ASOS hasn't done too much with data science or big data in general. But as other companies like Spotify, Netflix, or Amazon were already doing a lot of things in recommendations, we thought that might also be useful for us. So we started to look into a proof of concept, where we implemented a version of the algorithm, did an internal user test. So we are quite lucky that we have a lot of people who are actually also in our target group as our employees. So we put recommendations in front of them and looked into how does it work, do they like it, what are the issues with that, collected their feedback. We also did a customer study where we invited some of our customers to rate recommendations, give us also qualitative feedback. I'll show some of that in a bit. And that helped us to kind of get a feeling of, does it work? Is it worth pursuing? And is it something that we think will be successful ultimately? After that, we got the go-ahead, and we went to build out the recommendations engine, which meant that we built out the entire infrastructure for that. We scaled the computation, and we also decided to do it ultimately in-house. These days, you have a lot of companies who offer recommendations as a service, but we felt because we have all the fashion knowledge, we have the domain knowledge, it makes sense for us to actually do it in-house and use and leverage our capabilities. And we started to roll out recommendations on the app. There's a section in the app where we provide a curated list of products for each customer. The next step for us was then to roll it out to additional propositions. So we're using recommendations on the product pages, on the category pages, in emails, and some other parts. And the next phase was then all about improving the relevance of the algorithm, making recommendations better, and also internationalizing them. So initially we had it on the .com page, but more and more we're looking into rolling it out in the other pages and making it available to all of our customers. So recommending fashion, what are the issues? What could go wrong? So all of these quotes are feedback that we got on the back of our initial customer study. And they were quite interesting for us because initially we started working on a model. We did a bit of offline testing. We got different metrics and different values for our metrics. We were quite happy with that, but then there were a lot of things that we didn't foresee and that the offline testing and the metrics don't tell us, but that customers are very aware of. So recommending fashion is a very personal consideration because people are quite passionate about fashion. They're quite passionate about what they wear, and they're also very opinionated. So on the one hand, they expected us to know a lot about them. So they were like, oh, this doesn't fit my shape. This is not my favorite brand. I never buy, I never buy a waistcoat. Why would I ever buy one, or why would I like that? So one of the main challenges that we had was that the data that we have about users is very sparse. So our customers, they shop on the site about twice per year, and in each shopping instance, they buy about 2 or 3 products. So which means we have like 6 very strong signals per year from a customer. There are also like things like views or saves or other interactions. But in general, the signals that we have is very sparse. And then it becomes very difficult to actually infer what the customer wants, what does he like. Like we have positive signals, but there are a lot of products that the customer never sees, right? So if you never buy a certain brand, does it mean that you're not interested in the brand or that you just never have seen the brand? And this is one of the main challenges, and still is, that we have to deal with. So one of our considerations was, what sort of algorithms can we choose? How can we improve the algorithms to actually work with sparse data and allow us to make the recommendations better? Then another challenge is that we have, as said, about like 85,000 products available on the site, and these keep changing constantly. Right? So in other areas, like for example, music, songs probably never go, they never disappear from the platform, or maybe also like videos like Netflix. New ones come in, but they never disappear. But in our case, products come in and they change and they get sold out. And also there's the whole sizing issue, right? So a recommendation might be very good for you, but if it's not available in your size, then there's no point for you to actually kind of buy it or look at it twice. So this was another challenge where we kind of now trying to look into how can we make the recommendations smarter, how can we take into account additional data like the sizing to make the recommendations more size aware. And then another key consideration for us is the pricing of the products. So we had some feedback from customers that they really like the products, but the price is not right or it's just too expensive. A lot of our customers are young students. They don't have a big budget. So if we recommend any sort of more expensive items, they're not really satisfied with it. And also everyone is just willing to spend a limited amount on fashion. It's not like music where you can just listen to hundreds of songs. But affordability was a key concern. Beside of that, yeah, there's the whole discovery versus filter bubble problem. So to what extent do we want to show items to people that they might not have heard of before? To what extent do we just serve you what you already know? So this is a constant issue for us still, and the only way around it is to test and to experiment and basically see how we can improve it. So to tackle the whole fashion challenge, there were a couple of measures that we took. One of them is definitely that we understood that we have to take domain knowledge more into account. So we're working more closely with people in the business to actually understand what are the pain points, how can we tackle them, how can we approach them. We looked into doing more work around the cold start problem. So if we have new products where we don't have a lot of underlying data, how can we actually deal with that. How can we get better in inferring preferences? So there we are looking into how can we use additional signals, and also how can we qualify signals more. So for example, people might view a product, but if you only view a product once and then never go on to buy it and never look at it again, is it actually a positive signal or not? So we, for example, build a model to predict or to look into how predictive a product view actually is. So if you view a product probably like twice or 3 times, if you go in and zoom and look at the catwalk, then you're probably more interested than if you only look at it once. And also depending on the price. So traditionally, higher priced products, you have to look at them a couple of times before you buy them. So this is something that we're looking to take into account now. And we're constantly also experimenting with how do you deal with the different signals? How do you deal, for example, with returns, right? So people bought it eventually, so it's a strong signal, but they returned it. So is it then a negative signal or not? And this is something that ultimately we just can address with offline testing and also online testing. So I'm not going too much into detail about recommendation algorithms today, but just the 2 main concepts in recommendations is collaborative filtering. One of them is collaborative filtering, which is, in a very simplified way, it's a concept of people who buy this also buy that. So it's something that some of you who shop on, I don't know, Amazon or something would be quite familiar with. And this is a very strong and powerful concept because it allows you to derive information from the product without actually knowing the product. So the algorithm doesn't actually have to understand that this is a jeans dress. It just looks at the people who interact with this jeans dress, what other products do they interact with, and then we can understand what are sort of kind of related products. So in this case, I think these are actually recommendations that came up, or associations that came up. And the algorithm understood, so to say that these 2 dresses are quite similar and that they might appeal to the same type of customers. The advantage there is obviously that you don't have to know too much about the product. It's based only on the collective data, but this is also one of the potential limitations. So the algorithm only works if you have a lot of data available. So if you have very new products that haven't been sold yet, that haven't been viewed yet, then this is an approach that wouldn't work. So this is also something that we're seeing. We're getting a couple of thousand new products on the site every week. And for these products, we can't use this standard algorithm. So there, content filtering comes in. And this type of algorithms looks more around at actually the product. So in other industries, it would be like at looking like things like music, who's the singer, what's the genre, and so on. In fashion, this is obviously around more like the product range, the brand family, the price point, style, color. So obviously these 2 T-shirts are quite similar, and we can pick up on that just looking at the product data, and there's no past history required. But for this type of algorithms to work, you have to have a rich source of actual product data. This is also something that we're working on right now to improve, because in the past, the sort of product requirements or product data attribution requirements that we had were quite different than to the ones that we have now when we want to do more complex and more interesting things with data science. So we're looking into kind of enriching the product data that we actually have, and also looking into how can we use, for example, the images more to build up our knowledge about our products. In terms of the underlying algorithm that we actually use, we use matrix factorization. This is one of the standard algorithms that you would find in recommender systems. The idea here is that basically you put all the items, all our products and all our users, our customers in a big matrix. And based on if the customer has interacted with the product, we have an entry in the matrix. And we can, this is quite a nice concept because we can use the different interaction types that we have with products in here and use different weightings. So things like views, buys, saves, add to bags, we can come up with different weightings for that and use them in here. As I said, most customers only interact with very few products, so the matrix is ultimately quite sparse. Right? So there would be a lot of zeros in there and just kind of a couple of 1s, 2s, 3s, 4s, whatever we use for that. But matrix factorization helps us to break that down into a lower dimensional representation, so these factors. And ultimately, we break it down into 2 low-dimensional matrices, where we have 1 for the items, and for every item we would have 1 vector that builds a very nice profile of the item, and the same for the users. It builds a kind of very nice profile of our users with just one low-dimensional vector. And we can then use that to actually map our users and the products into this concept space. And this can then be used to, so every user and every product we can map into a concept space. So this is just a simplification where we could say, in terms of price preferences, brand preferences, color preferences, this is where the user is positioned. And using a technique like this, we can ultimately compare every user to every other user and every user to every product. So at any time, we can come up with an affinity score almost for any sort of user compared to any product. And we found that it's a very useful concept for us because it allows for a lot of flexibility, and we can use it quite easily across different propositions, right? So if you want to do recommendations on the product page, then we can just look at which products are similar to the given product. If we look at it in terms of category pages, we could easily just rank a list of products for each user. And this is quite nice because it fits very well into the same architectural concept in terms of serving recommendations. This is actually an example of us using these product factors and coming up with a representation of how closely related the different products are to each other. So this is a graph of all of our products. And just using these product factors, we came up with a network. And we can see that, not surprisingly, the products from the same category come up in the same region, but we also see overlaps between categories. And this is something that we can use in a lot of different propositions. So besides the main algorithm, or besides the actual data science model, we found that domain knowledge is a very important part of our actual algorithm engine. So besides implementing the actual algorithm, we did a lot of work in cooperating with different retail teams. So we talked to stylists, buyers, merchandisers to understand what is the sort of science, more or less, that they apply in their day-to-day work, and how can we either incorporate them in the model, or how can we use it to correct the model where the model is wrong. So for example, we have a maternity range. And then people who buy maternity clothes, they ultimately also buy other clothes, right? Because they're not pregnant forever. So in our data, right? So in our data, we would see that if you use something like collaborative filtering, you would see that maternity items are also related to normal items, so standard items. But if you recommend maternity items to someone who's not pregnant, then this might not be a very good idea, right? So this is something that where we then said, okay, how can we, what are good rules so that we can take care of that? And thinking then about things like we only recommend maternity items to someone who has bought maternity items maybe in the last 2 months, because then they might be still relevant for them. But if they haven't never bought it, we wouldn't recommend it to them. Or other things like how can we enrich product data? So we know that people, some customers buy looking at brand families, or they're like very brand focused. So they might only be like in very sporty brands. So we looked into kind of how can we cluster our brands better to understand which are the sort of sporty brands that one of our buyers actually would go out and buy when looking at sporty brands, and then bringing that knowledge back into our algorithms and models. And also, something that we found very useful is to do a bit of quality control when we're looking at the output of our models. So quite often in data science, you just look at some key metrics when you compute your recommendations or predictions, and just look at some basic recall or precision values. But what we found is very useful is basically just to kind of say, okay, these are all the recommendations for the users, and just pull them up on the screen, look at it, and then ask some people around the business to see whether this makes sense. And also for us, this was very useful just to actually see what we would serve to users. And by that, get an understanding whether it makes sense, whether it doesn't make sense. So for example, we were looking at doing outfit recommendations, and for that it's very important just kind of see what does the algorithm come up with. Does it make sense? Would it suggest things that are completely out of the way or not? And besides that, obviously just a lot of testing and getting feedback. So when we're validating our models, so besides the sort of visual control, we're looking at 2 main avenues. One is offline testing and the other one is online testing. The challenge that you have in recommendations especially is that I would say the sweet spot in recommending items is actually recommending something that you wouldn't have found yourself, but which you still like, right? This is kind of where the benefit from recommendation comes from. And this is something that's very difficult to test offline, because offline you can only use historic signals, and there you would only see the items that the user has found himself. And that quite often, this might just be items from the same brand that you always shop, and you don't necessarily need recommendations to help you find these items. But still, we have to use offline testing because we have a lot of different algorithms, a lot of different parameter settings. So we need offline testing to have a first filter of our algorithms. So we use it to narrow down the variants of algorithms that we want to test ultimately, and have a first, as I said, control step. And you have to ultimately just be aware of the many limitations that you have in offline testing, which are things that, like, you're never able to simulate the entire package of the data product. So whenever we serve up recommendations, there are a lot of other things that play into it. So one is the whole sort of visual representation, maybe the UX around it, the UI, the sort of wording. So whether I say this is recommended for you or these are your top picks might already have some sort of impact on whether you like the recommendations or not. And this is something that you can't replicate offline. But nevertheless, we use it as a guideline to see what sort of algorithms we want to put forward for online testing. Online testing then allows us to actually test our algorithms in real life, put it in front of customers. But obviously the limitation there is that we only have so much traffic. Online testing takes a bit of time. It might take a couple of weeks or even longer, depending on what it is that you test. And you can only test so much in that time. So you really want to be able to just put the most promising algorithms and models in front of the customer. But as I said, like, you have the benefit that it takes into account any sort of external factors. You can test different visual representations and ultimately also confirm your offline results. So some work that we're doing right now is looking into how can we actually bring together the offline and the online results, and how predictive are actually the offline testing results for online testing. So we've seen that we have some applications where this is more the case, but then also other applications where where the offline testing results are not that helpful. So for example, if I provide you with alternatives for things that have gone out of stock, this is something that's very difficult to test offline, because you might have never bought the products from products that are ultimately substitutes, right? So you might not need 10 pairs of the same type of black shoes. So this is something that's very difficult to test offline. But yeah, I think we haven't found the ultimate solution for that, and I haven't heard of any company who has. But yeah, I think the only solution is just kind of to keep experimenting with that and trying to find a good balance between those things. So in terms of the recommendations engine that we have, this is just a very simplified representation of it. We have all of various data sources like customers, products, clickstream data, transactions that we make use of. We built a data processing pipeline, and all of that we do in our batch process, so that's done offline. This is where we do the heavy lifting and the actual machine learning models, and at the moment we do that on a daily basis. We use the Microsoft Azure platform to do that, and in our data processing pipelines we use the Hadoop framework. In the past we used more of Pig and Hive, but recently have moved to more Spark and Scala to just do a lot of data cleaning, data preparation. Then ultimately we have a machine learning model in there where we do things like matrix factorization, and there we use Spark, Scala, Python, and also now starting to experiment with other frameworks like TensorFlow and other bits. And then the output of this batch process are then either data sets or model elements. So for example, for the matrix factorization, we come up with these two matrices for users and items, and that's something that we can then deliver to the online engine, which is more the real-time serving layer for recommendations. And this is actually the engine that the user or the front end interacts with. So whenever we serve recommendations, we have an API where the request comes in. This then goes in and looks at the computation logic based on whatever is the proposition, and uses the data elements to actually compute or put together the recommendations in real time, depending on what sort of service we're looking at. As I mentioned before, data science can't happen in isolation. There are lots of dependencies that we needed to manage. And this is, I think, also something that we underestimated a bit up front, where quite often you're just very focused on your own model. You're focused on optimizing the model, getting good results for your metrics. But then there's actually a long way before putting it into production. So when we started with a recommendation system, we were basically disrupting the status quo to some extent. So this was something new for the business, everything around big data, machine learning. So there was a lot of communication we had to do about what is actually that we're doing in data science, what do our models do, what is the power of the models, what are the limitations. So we're still kind of going around a bit the business all the time, just trying to educate people, making sure that they understand what we're doing, and also just trying to prevent any sort of considerations or concerns that people might have around using data science in the fashion domain. Also, we're working with technologies that the business hasn't worked with before. So there was a lot of time went into actually choosing the right technology tools, thinking about how does it fit in with the rest of the company architecture. And also because in the data science space, obviously, we constantly observe that there are more and more new technologies coming out. So how can we actually incorporate them? How can we make sure that they fit in to our landscape, and that we have the right balance between choosing the best tool for the job, but also standardizing across teams and across the company ultimately. And then there are a lot of dependencies with other teams, especially if you're doing any sort of data product work where you have front-end facing models. So for any sort of things that we do, we want to put it in front of the customer. So there's a lot of integration with web pages, with app. So the front-end development, we need to think about what's the UX, what's the UI around it, and how does it fit in with everything else. So now to some examples of the recommendations, propositions that we actually implemented, and the sort of challenges and issues we had around that. So this is actually the first recommendations application that we launched for the customers, where we have our app, and in there's a section that says, here you can have some recommendations, and then you get a list of curated items where you get, I think at the moment, 30 items. You can say what you want, what you like, what you don't like, then go on and buy it. So that worked quite well in the sense that it was a phased rollout. So we were able to really test our potential of our recommendations engine and make sure that it works, that it satisfies the requirements of a growing user base. And we observed that it's better in conversion than compared to unpersonalized sections in the app. But the issues that we had with this was that it was a new destination, and we quickly found out that it's quite difficult to get customers to a new destination. So they were not used to interacting with that section. And we saw that initially when we were doing some promos around that, traffic went up, but then it slowed down again. And also we had to realize that the relevance of the algorithm was not as good as we wanted it to be. So the next step, we looked at the product pages, because we thought a new destination is difficult, but how can we integrate it into the existing customer experience? And product pages are a natural touch point, and we put in this you might also like carousel in there, where we serve similar items. This went quite well. We saw a high increase in conversion compared to the status quo, which was at that time just a very basic rules-based suggestion engine. And also by improving the algorithm, ultimately now to matrix factorization, we saw another significant increase in conversion. But the issues that we saw there was that usually when you arrive at the product page, you're already somewhat at the end of your discovery journey. You might just want to buy the product and then you're done. And also because that part of the site is quite far down, it historically has a bit lower customer interaction. We also looked at out-of-stock pages, because previously this was just like a dead-end journey where a product was out of stock and there was no alternatives. So we decided to put, again, like similar items down here. And that worked quite well. People interacted with it, and we saw an increase in conversions. But the main kind of question or issue there was that we don't really know what it is that the customer is looking for at that point. So you might be quite keen on a specific price point, or you might just want to buy a dress for a wedding, and then you don't maybe don't care that much about the color, but you know which sort of shape of dress you want. So this is something that we kind of have to work on and refine. We also looked into putting recommendations into emails, just personalizing the content in there a bit more. This is obviously kind of a quite easy thing to do, because you can very easily validate algorithms, because it's a bit more independent from the rest of the web page and requires less integration. But we saw that there are very specific use cases, and we needed to find a way to be able to scale to all of these different specific use cases and make it quite easy for the rest of the company to consume our recommendations products. Then another major implementation of recommendations for us is the category pages, where we looked into personalizing the top items in there. Just, I think, the first 12 top items. And this was quite successful for us because we were able to do it in a bit of a hacky way that allowed for a quick prototyping and therefore iterate on that quite a bit. And because it was successful, we were then able to go ahead with the full rollout, which we are doing right now. But yeah, potential issues there is that we don't know yet what is actually the best combination between human curation and designing a nice category page versus recommendations, where you're never quite sure upfront what sort of products come up. So this is something that we're also investigating long term. Besides testing different propositions constantly, we're also looking into identifying what are the best tools for the jobs, as I mentioned. So right now we're mostly using the Spark framework, but we're also looking at other frameworks, and there we are looking into how can we leverage what other companies have already done. We're looking into existing research, but also already built open source tools, like a couple of frameworks like QMF or LibFM or LightFM that are known to be quite powerful and useful. And obviously we need to find out what tool works best for our specific use case. And also we're looking at things like Keras or TensorFlow to see how can we work with deep learning and make it integrated into our algorithm pipeline. So what's next for us in terms of the work on recommendations, mostly around optimizing the algorithm, optimizing the model. So there are some other things that we're doing in terms of internationalization, but these are some other teams that are working on that. Our focus on data science is always looking into kind of how can we make the model better, how can we be closer to what the customer actually wants, how can we infer what it is that the customer wants. So things there are context recommendations, so specific occasions, people usually buy for specific purposes, so they're going on a holiday, they're going to a party, a festival, whatever, so how can we actually identify what it is they're looking for? And there we are especially looking at making more use of real-time data, session intent, what is the customer looking for, how can we adapt our recommendations to what the customer is looking for currently. Also, we're looking into things like outfit recommendations, how can we actually combine recommendations across product categories and make it a package recommendation almost, where we then say, okay, based on maybe what you bought last week, here's everything that goes with that, and that's quite a nice package. And then we're also always looking into additional propositions, so where there are other touch points around the customer journey where recommendations or personalization could be useful and where we can implement it. So that was a lot of information about how we do recommendations at ASOS. Thanks for attending. If there are any questions, I think we have some time now. Otherwise, we have also a stand outside with some more colleagues. So if you're interested about data science at ASOS, just come and find us. Thanks.
Hi. That was a really insightful presentation. Thank you.
Thanks.
I was wondering, in terms of the models and also conversion, how do you decouple what you recommend versus how you recommend it? And in terms of conversions, have you seen one of them working or is more significant than the other? And what experiments do you do to take those apart, for example?
Sure. By how we recommend it, do you mean where in which?
What you like, pictures, colors, sizes,
Okay.
text, those. Is that more important, or the product itself that's what you're recommending is more important?
To be honest, we don't have an answer for that. So it's very difficult to decouple those things. That's why we see that online testing is very useful, right? So in offline testing, you could just focus on the algorithm, but as soon as you put things online, there's so many other things that influence the customer decision, right? So it might be the current stock availability, it might be the header, it might be where it is on the site. So this is something that we have not been able to split out in the past, but we're looking into optimizing across both dimensions. So for example, now with this carousel, we have a couple of algorithm variations that we want to test. So this will tell us to what extent do these variations actually impact conversion. And then we have a couple of suggestions for actually changing the interface, changing the wording, and we're looking into doing extra tests, separate tests for that. And I think the only way that you can actually test it is if you have more variants around the test. So for example, if you have 2 variants for the interface and 2 for the algorithm, then ultimately you need 4 groups to actually test that. So this is something that we're looking into right now. But I think I've heard from other studies that quite often actually the interface might be much more powerful than an actual algorithm improvement, which is not great for us, but something that we have to work with.
Hi, firstly, thank you very much for the presentation. Very insightful, as you said.
Thanks.
You mentioned data scarcity as being an issue for you. So, for example, somebody would interact with your site twice a year. How do you marry the divisions of your data into things like seasonality trends, weather trends, with the credibility of those data cells, given your lack of data?
So on the one hand, we're trying to look at the larger time frame of data, right? So we thought about what is the good time frame. Do we just look at the last session? Do we look at what the customer has always done, the entire customer history? And we settled on like a time frame of like 1.5 years, so to kind of give us at least a sizable amount of data to deal with. But something that still remains a bit of an open research area for us is to what extent should we balance the sort of short-term signals versus long-term signals, and I think this will very much depend on different customers, whether they some of the customers just shop in a yearly fashion, just for Christmas, some come back every week. In terms of seasonality, we see that the recommendations sometimes follow a bit of a trend. So obviously, like if you look at recommendations in the winter, we would see much more winter coat items and so on, versus the summer where we see other items. What we try to do there right now is, for example, looking into separating recommendations for different geographies, right? So how does that work out? Having one global model versus, for example, doing a separate model for, Australia.
Credibility in terms of homogeneous risk groups. So if you don't have enough numbers in your risk group, then you can't weight that data.
Yeah, so I think ultimately the only thing where we can learn that is by putting it in front of the customer and seeing if the recommendations are relevant. So I think, just kind of basically by looking at our KPIs to see whether there are any sort of specific areas of issues that we can identify. So as I said in the beginning, so for example, things like new products. These have been a bit of a challenge for us because there you have only very few data points. What do we do with that? Or then people with few signals, we found that, for example, if we do more product-focused recommendations, like, for example, the product page, this still works for them because there you can draw more from other customers because we already know that you focus on this product. Yes, so obviously it works a bit different across different propositions, but I think this is also one motivation for us to try to be in different points of the customer journey. So if then one part of the recommendations might not work out for you, maybe there's something else that we use.
Thank you.
I think there's a question in the back.
How do you make recommendations for those customers who hasn't had interacted with the system, with your website at all, for which you don't have any user profile?
Sure. So basically, it depends again on the proposition. So something like this that we're doing in the app, we can't do for someone who has never interacted with the app. So there would just not be any recommendations in here. If we're looking more at things like, again, something where we have a different anchor, where we can say, we know this is your current interest, we can base it on that. So then we could just say, okay, regardless of whoever you are, you're looking at this product, so we know that other people who have looked at this product, they're doing this and that, and this is what we're then trying to do. And ultimately where we want to move to is then being in a position where as you browse the site, we can pick up on all of these small signals and build up then an increasingly more comprehensive profile of you and just pick up on your signals. But yeah, it is very difficult if we don't know anything about you, then there's not much that we can personalize for.
Thanks.
I'm just wondering, it's really fascinating some of the work that you're doing there. I'm just wondering, in the course of either trying to distinguish what the problem space would be in a sense, and researching around that, if you looked at other industries or other sectors that are currently working with that, and what lessons you might learn from those sectors. Yeah.
Sure, yeah, we definitely do that. Especially in the beginning when we were starting out, the first thing to do is actually looking at what do other people do, either in the same industry or other industry. And traditionally, like when we started out with recommendations and everything, still now the big players are people like Netflix, who do a lot of recommendations, or still companies like Spotify or Amazon. So we tried to look into what are the sort of things that we can learn from them. So definitely things around the algorithms, right? So the field is constantly being advanced by a lot of people in the industry, so we're always having an eye on that, attending conferences, looking into research, what's happening there, what can we take from that. But we also always try to look into what is specific to fashion. So what are things that we might not be able to replicate? So things like there's always the price concern. People only shop so much in a year. We only have few signals. How can we cope differently with models? But there's also, if other companies are coming out with new things like Discover Weekly and Spotify, which has been quite a success, we might look at that and think, how can we replicate that for our circumstances?
I have two questions, if possible.
Sure.
The first one is, have you ever tried to explicitly ask the users what do they prefer, like a questionnaire, like you are showing them pictures and they either like or dislike and comment why do or not like? And the second question is again about getting the data. Do you somehow interact with other websites like, I don't know, Google, Facebook? I mean, I as a user definitely notice that the sites do interact with each other and know my interest in one website. So I'm wondering whether you can somehow do this and do or not?
Sure. For the first question, so yeah, you will definitely have a lot of companies who do that, especially in the fashion space. You will have companies like, I don't know, it's Stitch Fix, Thread, or who have like these questionnaires. We thought about doing that, and we're still, I think, in the process of considering this. It comes with a couple of challenges. So one is that we don't know to what extent users are actually willing to use that and fill that out, right? So if you're like a very engaged customer who shops with us all the time, then you might be more interested. But then other customers who only shop like with us very rarely, they might not be that much into it. We saw from like initial studies that we've done that users already expect us to know a lot of them about them. So we'll see. So yeah, we're trying to work out how can we actually make it easy for the customer to give us more details when he wants to, but still be able to basically guess or infer what are the preferences if he doesn't want to do that. But we're still trying to find the optimal sweet spot in there. And then the second question, sorry, was about.
Whether you use data.
Oh, sorry. Yes. So yeah, you will see that, for example, if you are on the ASOS website and then go to Facebook, you might see some ads there. So this is all, this is a different process. So this is just retargeting that basically is, I guess, the core of Facebook concept. But also when you sign up for ASOS, then you have the opportunity to sign up with third parties like Facebook, I think Google, or is it Twitter now? And then you can choose the sort of data that you want to share with us. So I think there, you can choose to authenticate us, and then if you choose to do that, then we would have access to that data.
Right. So if a user doesn't explicitly give you consent, then you cannot do that.
No, we can't. Definitely not. But yeah, if you would notice, like all of the web, if you kind of are in the same session, if you don't delete cookies, then obviously the web knows where you've been. But we wouldn't be able to actually know what you're doing on Facebook. We just know that you've been on ASOS and.
But you can analyze the profile if you want.
Well, no, only the public profile. If you don't give us the consent to kind of get anything else, we could only try to find you and look at the public profile. But that's usually not too helpful. Cool.
Hi, hello. A quick question. Do you see consumers becoming more tech savvy? What I mean by that is, as a consumer, when you know that you will use my feedback to give me a tailored recommendation, then I have a much greater incentive to tell you whether I like that jacket or not.
Yes, so we definitely know that consumers are becoming more tech savvy. On the one hand, because different industries are pushing for that. So you're more used to kind of providing your data, providing your feedback, and getting personalized experiences. What we definitely notice is that at the point where you, on the one hand, ask consumers for more feedback, the expectations also increase a lot, right? So if I don't provide you with specific data and you recommend me something that's not great for me, I might be like, okay, that's fine. But if I tell you this is what I like and you come up with a wrong thing, that's a different.
But perhaps it tells me that I need to give you more feedback.
Yes, that's true. That's true, but I think that goes a bit along the question of the lady besides you, is that we still kind of, I think, trying to work out what's the best combination of asking for explicit feedback versus trying to infer things. So we might do some trials around that in the future.
Because, for instance, on your website at the moment, there is just these little heart-shaped buttons, which I can click on if I like it. But what if I hate it?
I could
be indifferent to the jacket, or I could absolutely hate it.
Yeah, so this is something that actually only on the app in this My Recommendations section we have this sort of thumbs down, and we
Okay.
see that people interact with it quite a lot. So
Okay.
there's obviously the need for us to tell us if they don't like something.
Yes.
But yeah, I think we've been discussing including that in different parts of the site. But there's again like pros and cons against it. From a data science perspective, I would love to have that because it just means more data for us, and it would be great for us. But there are other people who have a
Sure.
different opinion on that. But
Thank
anyways,
you.
no worries.
Thanks for a really good talk. My question is, do you ever find that you kind of get positive feedback in your algorithms? So because you surface recommendations to people, they're naturally more likely to be clicked on. And whether you have to kind of account for that in your algorithms to make sure that it explores the full space of possibilities, not just presenting the same stuff each time.
Yes, that's definitely an area of concern, is the whole kind of topic of presentation bias ultimately, right? So I think this is something that we have to be more aware of the more and more we're starting to spread out recommendations across the site. At this moment, we're still at the stage where there's a lot of the customer interaction with our products is not driven by recommendations, so they still have a lot of avenues where they just kind of basically find and see what they like. So for example, on the category pages, when we looked at personalizing those, I think the initial idea would always be that we only personalize parts of it and still allow for the customers to find content in a different way. But yes, ultimately, there are different techniques around that to allow for a bit maybe of randomizing of the traffic, right? So you could always say, in any sort of online testing, I subject 90% of the customers to my algorithms, and 10% are just preserved for randomizing. I also just try to maybe elicit feedback for areas where I'm unsure. So I might intentionally show you something just to kind of get your feedback, right? Maybe a new brand, just to kind of see, oh, is this something that you kind of go on and like? But yes, it's definitely kind of something that we think about in online testing.
Right, so sorry to stop the questions now. We have a coffee break now until 3:30, and we can ask her more questions outside, I guess.
Yes, and as I said, we have a stand outside, so just come and find us.